also had a few questions about volcanic activity and monitoring in the North Island from Michelle and Penny. So Michelle asks, is the current volcanic activity, volcanic and tectonic activity around Lake Taupo, White Island and Mount Ruapehu linked to the Hikurangi Subduction Zone? And does it signify anything about a potential earthquake? And in a similar vein, we had a question from Penny related to some of GeoNet's monitoring equipment in the far north. There is both an earthquake and volcano drum in Omahuta, which I hope I'm saying right, in the far north. I've noticed over the last few weeks that the drums have been much more active than usual. Two cones I'm aware of are Rangiputa and Mount Camel. What are the other volcanic cones that are being monitored, as Omahuta is a fair way from those cones? So I might put this one over to Tom and also Caroline. So Tom, can you explain what we know about the relationship between the subduction zone and our volcanoes? Could a Hikurangi earthquake trigger a volcano or increase its pressure? And what about the activity in the far north? And also to Caroline, perhaps you could explain a little bit more about this monitoring equipment and what it's telling us. So over to you, Tom, first.
Sure thing. Good evening. And can I just say how pleased I am to be talking about volcanoes on a AF8 and Hikurangi public talk. This pleases me immensely. So New Zealand is on a plate boundary, a tectonic plate boundary is the place to start with this. And where we have the Pacific plate subducting underneath the Australian plate in the North Island, that's what gives us our Hikurangi margin. And that process is where those great big earthquakes come from. But also what happens when that plate is subducting down is that it's because it's full of water and other bits and pieces, as it heads down into the Earth's crust, it starts to melt. And what we have is this zone of volcanism that happens through the central part of the North Island. We call it the Taupo volcanic zone. And that's what's happened from when that crust is, or the plate is subducting down and it's starting to melt and magma's rising up through the Australian crust and creating that line of volcanism. And that's why we have Ruapehu, Tongariro, Taupo, Okataina, Whakaari volcanoes, all on that lovely big line through the central part of the North Island. So it is all connected, and it's all part of New Zealand being this amazing geological extravaganza that we live in. In terms of, yes, we've definitely had some enhanced volcanic activity over the last couple of years, but particularly in the last couple of months, where Ruapehu has been in what volcanologists call unrest, where it's got hot and there's been earthquakes underneath it, and it looks like it's there's been a little bit of deformation around the volcano. So that's where you will have seen some of the media reports showing that GNS Science has raised the volcano alert level to 2, which means heightened unrest. And Taupo volcanoes also had some earthquakes underneath it too, which probably means there's been a bit of magma moving around or a bit of deformation there. Whether that's really interesting in its own right, and for people like me who love volcanoes, well, me and Liam, I should say, because Liam's also a closet volcanologist, is that it gets quite interesting. But in terms of whether it's something that's going to forecast or give us any indication around a large earthquake on the Hikurangi Subduction Zone, is we can't make that connection at all. Where it gets interesting is there's quite a lot of science going into whether big earthquakes relatively close to volcanoes can trigger eruptions. There's certainly a lot of thinking that it appears that an earthquake can unsettle a magma chamber, or if a volcano is kind of close to erupting, you have a big earthquake, that might be the thing that allows it to get its act together and erupt, so to speak. I don't mean to trivialize this, it's very serious business. But that's sort of more the relationship that the current science is understanding. Sorry, my screen's just frozen there. I was just looking back at what the other question is. So I guess a Hikurangi earthquake, if it were to occur, one of the things that volcanologists in New Zealand would be worried about is what does that mean for our volcanoes? So there'd be a lot of close monitoring going on there. In terms of what's happening up in Northland, that's really interesting. I hadn't actually heard that there was more enhanced earthquake activity at all. But Northland's an interesting place where it's got three what we call volcanic fields, where the volcanoes up there tend to erupt little batches of basaltic magma, which basaltic magma is really low in silica, so it's really runny, and tends to have, when it erupts, it's not particularly explosive. It's quite these beautiful sort of big fire fountains that can occur, not like what we saw in Tonga a few months ago. So the up in Northland, there's 3 volcanic fields up through there, and there's relatively limited monitoring through those volcanoes. Both many of them aren't regarded as being terribly active, although one of them, I think it's the Bay of Islands volcanic field. I think there was thinking that it's some researchers suggesting that it's about 1300 years ago or 1800 years ago there was an eruption. But this might be a good place to hand over to Caroline, who'll be able to tell us a little bit more about some of the monitoring equipment they use for looking at what volcanic activity might be occurring there.
Thanks, Tom. And yeah, I love the question because I love earthquake recorders. So the question I think was around what's the difference between the earthquake drum and the volcano drums. They're basically both seismometers. So they're instruments that record tiny vibrations of the ground, and they just come with different sensitivity. So for Tom, and now I know Liam, who's also a volcano expert now, it's important to be able to have those sensors that can record really small vibrations, because those volcanoes tend to be a bit more humble than like an Alpine Fault or a Hikurangi Fault. And then we have some sensors that can take a big punch. We put them next to where the likelihood of a large earthquake is increased. So next to Alpine Fault or big active faults, also near urban centers as well, because we know these can shake quite a bit as well. And so those sensors are a bit less sensitive, but they can take a bigger punch. And so they're allowed to get a lot of seismic data without being saturated. Yeah, so yeah, just tell you, I just love those sensors. I actually have one myself in the house right here. And it's kind of like an average one that can tell you when the washing machine is running, but also can pick up, the little 3.9 we had in Parapara Umu last week, I think. So these days they become quite affordable, and yes, I have one myself, obviously, but you don't need to get one, because we have in New Zealand, we have a beautiful national seismic monitoring network called GeoNet. And so GeoNet is really composed of a variety of those seismic sensors for obviously different purpose, whether it be volcano or large earthquakes. And we have more than 500 of those. The data, it's open data. You can just look at it on the GeoNet website. So you don't really need to have one in your house, but yeah, I really encourage you, if you can, to get more sensors. The more the better. So I'll just stop here because I could talk for hours.